Okay, hello, my student. Welcome to chapter 2 of the course of material testing. Uh, on the start of this second week, before go to the chapter 2, I like to talking about something that you as a future engineer supposed to know. First thing, we're supposed to understand the significance of this course of material testing. As a civil engineer, you may be the design engineer or the site engineers, you must have the knowledge of the property of the construction material, such as concrete, steel, and timber. Why? Because when we work and engineer, we have the duty to select what type of material going to use to build the structure, such as the picture below. We are the one who will follow that. If you select concrete and the steel, you're going to design the structure, analyze the structure by using the concrete reinforced concrete design manual. And if you select the steel as the main materials for building this structure, you're going to use the steel design manual for that. So it must be select properly which material you are going to use in building the material since the first step when you plan to build the structure. So if you select the material properly, your structure will be very effective and appropriate. Okay, and the other thing, the civil engineer also need to have the knowledge of testing the material. Why? When you design, you build the structure in the figure below with the reinforced concrete. This means you will buy the concrete from some company like a Siam Cement Group. You also buy the steel from the other company, for example, Saviria Steel Industry. And then when you buy that material, and then they send the material to your construction sites. So you got to check, do the steel have the material property in accordance with the specification that you use and you pay the money for. Okay, and the concrete also. If you buy the concrete from the Siam Cement Group with the strength of 32 megapascal or 320 kilogram per square centimeter, how do you sure that the Siam Cement Group gonna send you the correct cement, the correct concrete? You must test it. So every 50 cubic meter of concrete, you got to take some specimen, like 5 specimen, to test for its material property that's going to pass what you buy the concrete for. Okay, that means you're gonna check if the material used in construction have property in accordance with the design and in accordance with the money you buy. Okay, and also if civil engineer do not have proper knowledge on the material property, the engineer may cause at least 3 things. The first one, you may cause the damage and failure of the structure, or the structure may be deficiency. For example, if you design the structure with the concrete with the strength of 32 megapascal or 320 kilogram per square meter. And the concrete seller send the low strength concrete for you. Let's see, for 240 kilogram per square meter or 20 megapascal. What will happen? Your structure will carry less force than you are expected in the design. That means you're going to reduce the load that applies to the structure, or you may need to repair or strengthening it in order to get the structure perform as you expect. And the second, it may make the structure expensive or at necessarily higher cost of construction. For example, if you decide to build a structure with the concrete of 220 kilogram per square centimeter or 32 megapascal again, and then you buy the concrete with the strength of 480 kilogram per square meter and build this structure. So that means you're going to use very high so material, and then you're going to waste some money. Okay, and based on the item 1, if the structure built by the low strength material and you still put the force, put the load, put the people to the structure at the same as you design, this load may cause the under strength structure to be damaged or maybe collapse, and maybe cause maybe kill some people. So this is the importance of the material testing and knowledge about the material for a civil engineer. Okay, let's see some example for the structural failure. The picture over here occurred in Kolat many years ago in 1993. There is the hotel, and then the hotel was expanded or was changed from 3-story building into the 6-story building. And then one day there are people gathered in the ballroom of the hotel, and the load is too much and it caused the column to fail. So when the column failed, the whole building collapsed down and caused 137 people died and 224 people injured. Not only this happened in Thailand, it also happened in America. This is the picture of the failure of the Hartford in Connecticut. It is the civic center. This civic center roof collapsed due to the snow load. That is the white thing over here. It's too much and everything collapsed down. Luckily, no one is there during the collapse of the structure. If a lot of people using that civic center during the collapse, it would happen. A lot of people may die due to that. And also, there is some maintenance problem. This pedestrian bridge in the United States of America in North Carolina also collapsed in the year 2000. The cause of this collapse is due to inappropriate maintenance of the steel pre-stressing cable, and then it gets some corrosion, and then it's collapsed 5 years after in the service. Okay, for the engineer, you guys supposed to be very good in understand the material property and material testing and select a proper material to use. And Some material property that we supposed to understand and use, maybe consider the physical property and the mechanical property. Usually the physical property, when you buy the steel, you got to measure the size. For example, if you buy 25mm steel and then the company send you that steel, you got to go and check some of them are at the correct size or not. If not, just reject it back, return to the company. Don't waste the money on that. And also, you got to do some testing for the strength and the stiffness and the toughness of the steel. The industrial standard will specify the strength, the stiffness of the steel, and if you test this and then you get lower than the strength and the stiffness, again you should reject that material back to the supplier. There are some other material property but are not important for us. For example, chemical property, physical chemistry property, temperature property, electromechanical property, sound property, or light property. So mainly, as a civil engineer, you got to consider mainly the physical property, such as the size, the shape of the material, and the mechanical property, which is the strength, stiffness, and toughness of the material. What do we find the strength or the stiffness of the material? Again, go back to the chapter 3 of the mechanics of material. You know that we plot the stress strain diagram. The stress strain diagram is kind of fingerprint of each material. They represent the material respond to the force. For example, if you consider the first one, this one, the low carbon steel have the stress strain curve like this. It have the yielding stress here. And the second is the aluminum alloy. It has the curve here. The third is the cast iron. The fourth is the wood. And the last one is the fiber. If you consider the strength is the ability of the material to resist the force. So that means the low carbon steel will use the yielding, that is about 250. And for the aluminum alloy, you got use 0.2% offset to determine this yielding. And if you do so, it's going to be very close to the low carbon steel. And for the cast iron, the strength of this material maybe half of the low carbon and aluminum. And if you go to the wood, the strength going to get lower and the rubber is the lowest. See, so the strength is one important factor and is different from different kind of material. How about the stiffness? The stiffness is ability of the material to resist the force by changing the shape. If the material have high stiffness, it's going to defect or deform less, and if it have less stiffness, it's going to deform a lot. For example, the rubber have small stiffness or small modulus of elasticity. Usually, we measure the slope of the linear elastic part of material. That is the modulus of elasticity to represent the stiffness. So that means the rubber going to have smallest modulus of elasticity and less stiffness. And the wood gonna be stiffer than the rubber. The cast iron is stiffer than the wood. The aluminum alloy is stiffer than the cast iron. And the low carbon steel is the stiffest one. When you compare the structure, another thing is the elasticity. Elasticity, we are talking about how the material can deform in the elastic region. For the low carbon steel, it's going to be about 0.002. For the wood, it's maybe about 0.01. That means the wood has elasticity 5 times larger than the steel. Okay, for the plasticity, that's how the material can deform beyond the elasticity. And the last one is the energy capacity. We measure the energy capacity by the area under the Stesten diagram. The material that can consume large energy can tolerate to high impact force. Okay, and next, how many types of material testing we have? Actually, we have 3 main types, and only the testing for control, the first type, is important because it's the test that we trying to find the property of the material in accordance with some specific standard or specification. Okay, the quality control testing mostly done by the manufacturer. If you work with the Siam Cement Group to produce the ready mix concrete, okay, you do the quality control testing. Every concrete that's come from your concrete plant supposed to pass some specific standard and specification. And the 1.2 is for the acceptance testing. If you are an engineer at the site, you're going to buy some concrete, you're going to buy some steel, and the supplier going to send the concrete and steel to your construction site. Your duty is you got to check that concrete and the steel is pass or are passing the specification specified in the standard or not. So that means as the site engineer, you got to have the knowledge of property of the material and also how to test it. If not, you may get the material that's under the specification in the standard, and then when you build the building with those kind of material, your structure may be dangerous in the future. The second type of material testing is for research and development. This is mostly for the research and development. The research in the university, in the development in the company is good for the graduate study. And the third, the testing for the fixed data. So this one is the high-end, talking about the nanotechnology, those kind of things, using of synchrotron light source. And this one may not be really involved with us, who is the engineer, usually work in the construction site, do the design in office, or work with the construction material company. Okay, so in conclusion, we as an engineer only involved with the testing for quality control, both in the production, the manufacturer, or at the user level. Okay, this picture is talking about the lab, the structuring lab, very similar to one we have. We have the UTM in our lab, we have the loading frame to the lab, we have the crane to the lab, and we didn't have this. This is the earthquake simulation testing. Next, the standard. Some of the standards are built or specified to prevent the hazards that may occur to the consumer or to protect unnecessary loss of the economy. For example, if you buy the concrete with 320 kg per square meter or 32 megapascal strength, and then you get the under standard concrete with the strength of 240 kg per square meter or 24 megapascal. What happened? Your structure going to be under your design. The structure can be collapsed, or the structure may be fall down due to the low strength material that is hazardous for the life. It may kill the people. And also, if you strengthen that structure, that means you're going to put some more money into the structure to get the structure as you design, to prevent the failure of the structure. But you got to put more money on that. So following the standard are very important as the engineer. So every construction site is supposed to get the sample that the manufacturer sent to you and check if it's above the standard or specification or not. In Thailand, we have the Thailand Industrial Standards as the standards we use to control the quality of the material we use. And the TIS have some specification like this. The first set of number is tell the name of the standard, which is concrete masonry unit. And 2526 is the year that TIS 55 announced. Okay. And not only in Thailand, American also have their own standard. It's called American Society for Testing and Material Standard, or the STM. In the Japan, Thailand use a lot of steel from Japan. You got to follow the JS, the Japan's Industrial Standard. And also the Britain also have British Standard, the BS. So when you go to different country, you got to adopt the standard from that country for your work. The TS standard give you two things. One is the specification. The specification gonna give you some property that you gonna be used when you compare with the test result. For example, if you buy structural steel that in accordance with TIS 1227-3539, and then you buy the steel SM 400, that means the manufacturer gonna produce this steel with the yield stress during stress not below this or higher than this, ultimate stress higher than this, and percent elongation higher than this. And then if you get the steel at your construction site and you test it, everything past this, so that is a good steel. And if one of the property lower than this specific value, you got to reject that steel back to the manufacturer. And how do you get the property? The TIS provide you the testing procedure or testing method that you got to follow that testing method in order to obtain the reliable value of this property. Okay, the TIS give you specification, give you the testing method. There are some important TIS for the concrete is TIS 409-2525 this year. And the steel is TIS 20-25-53 that you got to follow. The TIS separate into two types. One is the legal type. The manufacturer must strictly produce the product in accordance with this symbol. For example, the concrete, the Portland cement, that's gonna produce, or is must produce by following this. And the other manufacturer may or may not produce the product in accordance with the standard. If they produce in according to the standard, they get this symbol. For example, like the mixed cement. And if you compare, why the Portland cement get this symbol, why the mixed cement get this symbol? Because the Portland cement usually produce the column and the beam. If the column and the beam of the structure fail, the building may fail. However, the mixed cement they use in the masonry wall, and if the masonry wall fall, the structure would fall. So some important thing must be legal. Will get this symbol, if not like this. Okay, that is the end of the first part of this second lecture, and I will go to chapter 2 on the second clip. Okay, bye.